Hey, welcome back to Mr. P House with Precal. This is Unit 1, Topic 4, Lesson number 6. We're going to be solving rational equations in this video. So starting off with a warm-up on what we had done prior. So when we were adding and subtracting rationals, then we had to find the LCD, least common denominator. So in this case, it's x minus 2 times x plus 3. Because whenever there is polynomials in the denominator, you can just simply multiply them by each other, and that's always going to be a common denominator, which in this case is the least common denominator. Now, when you look at question number 2, this is actually differences of squares. This is x plus 3 times x minus 3. So we have this factor is already here, and then this other factor. So it's x that. So this literally is the LCD. For this one, I can factor out the x, and that becomes x plus 5, and then the x is the same factor here, so we don't need to write it twice. It's already one of the common factors, and multiply it by x plus 5. Okay, so this factored down would be x minus 4 times x minus 3. And this one, two numbers that give you 20, a product of 20 and add up to negative 9 would be x minus... Nope. That's not going to work. So, let's see, 5 and 4, sorry. X minus 5 times x minus 4. All right, so it looks like we have three different factors on the denominator, so the LCD is going to be all three of them. So x minus 4 times x minus 5 times x minus 3. All right, so getting into solving the equations. In this case, these questions are basically proportions, so you can cross multiply to solve. So you can multiply like this because it's really just one rational equals another rational. When that's the case, then you can cross multiply it. Now, if one side has a plus, then you can't do this strategy. You need to do it a different way. So this would be really 7 times x. 7 times 5 is 35. And then equals 3 times 4x is 12x. All right. So then when you're trying to solve these, so these equations... Oh, I already said that. So now I'm going to subtract 12x from both sides, and that's going to end up giving me negative 5x plus 35 equals nothing. All right, so then I can subtract my 35 from both sides, and that gives me negative 5x equals negative 35. All right, then if you divide both sides by negative 5, then you get an answer of 7. So that was negative 35. Yeah, I'm having trouble with the pen, as always. All right, so there we go. So cross multiply here. So you're going to get negative 9x minus 3 equals negative 8x minus 4. Let's get the, I always typically, variables on both sides, like to move the one that's smaller. So negative 9 is smaller, so I'm going to move over to here. So I get x minus 4 equals negative 3, add 4 to both sides, and you've got x equals 1. All right, so in order to multiply, you're going to have to multiply by the LCD, which I know we've talked about in prior videos. So if you multiply by this, and over here, we've multiplied by this. So basically, I'm just multiplying both sides by 1, but I'm using the other factor. So this is really 1, because anything over itself is 1. Since both the denominators are the same, then the numerators must also be the same. So I'm left with x plus 3 times x plus 1, which if I solve gives me x squared plus 3x plus 1 more x makes 4x plus 3 equals x times x is x squared, and x times negative 4 is negative 4x. Okay, so now what I'm going to do here is I'm going to set it equal to 0. Add 4x here, add 4x here. So I end up with 8x plus 3 equals 0. Then I can subtract 3 from both sides. 8x equals negative 3. Divide by 8 means there's your answer. X equals negative 3/8. All right, so as I mentioned before, you can't cross multiply here. So we're going to have to take a different strategy. So this is really over 1. So I can't add these unless they are the same. So I'm going to multiply this side by x over x. That's really just multiplying it by 1. So that makes this x squared, and then they're over the exact same denominator in this case. Okay, so if I multiply this by x and I multiply this by x, well, the x's are just going to cancel out, but then I have to also multiply my answer by x. So if you multiply one thing by x, you got to multiply it all by x. So therefore, it's going to give me x squared, whoops, Always the issues. All right, x squared. Come on, pen. Try this again. So there we go. Oh, no. As soon as I press play, it stops working on me. All right, x squared plus 3x equals 4x. All right, let me just try this again from the beginning. So I'm just going to multiply all of them by x. So I'm multiplying both the left and the right side by x. So x times x is x squared. Just can't win with this pen. All right, now it's reset. Let's see if it works now. Yep, there we go. So plus 3x equals 4x. So let's see, subtract 3x from both sides. Be easier. Wait, no, it's got the squared. So subtract 4x from both sides. That's going to be 3x minus 4x makes negative x. We have x squared minus x equals 0. So when we're down to this point, now I can factor out x. So it would be x times x minus 1 equals 0. And set each factor equal to 0 and solve. So it looks like x equals 1 and x equals 0. Those are two solutions, two things that are going to make this true. All right, so when solving irrational equations, you may multiply or divide the equation by expression containing variables and cause the resulting original. These solutions are called extraneous. So extraneous means solutions that are not really solutions, meaning when you plug them in, it's not going to work because mathematically, like for instance in this case, if the denominator is 3, then that answer does not work because 3 minus 3 would be 0, and you can never divide anything by 0. So just because it makes both equations true, it makes one of them be a false answer basically, because then this rational wouldn't make any sense because you can never divide anything by 0. All right, so with that said, so this is really over 1. So we're trying to, in this case, we're trying to make them all have the exact same numerators. So I'm going to multiply this by x minus 3. So that gives me all of the exact same numerators, which means all the same denominators, which means the numerators are all the same as well. So we have x squared minus 3x plus 4x equals 12. Then we can combine like terms. We have x squared plus x equals 12. Subtract 12 from both sides. We get x squared plus x minus 12 equals 0, which then can be factored down to x plus 4 times x minus 3. And using zero product property, meaning anything times 0 is 0, set each factor equal to 0 and solve, and it looks like you get an answer of -4 and +3. Now, this answer is extraneous because like I mentioned before, if you put 3 in for x, 3 minus 3 would be 0, and 12 divided by 0 is, it's going to give you an error message because that's undefined. So in this case, -4 is the only solution because the other one is extraneous. All right, so we can cross multiply in this case. That would be the easier way, or you can multiply both sides by the other factor. So this is basically what you're going to do anyway. Cross multiply is going to give you 6x minus 18 equals 7x minus 28. Move the smaller one. It gives me x minus 28 equals 18. Add 28 to both sides, and you've got your answer. So we've got x equals, in this case, 46. Now, if I put 46 back in for x, does it make any sense? Yes, it does, because 46 minus 3 works, and 46 minus 4 is not 0. As long as my answer is not going to be 0, then it is fine. All right, so these are all over 1, so I'm going to multiply both sides by x. These cancel. All right, so then now they're all over 1. So that's x squared plus 5x equals 14x. Subtract 14x from both sides. And 5 minus 14 is going to give you -9x. I can then factor out x and get this, which means it looks like my answer is 0 and 9. Now, let's talk about that for a second. So if x was 0, put 0 in for x right here. 14 divided by 0 doesn't make any sense. So this is an extraneous solution. But the 9 does work. So 9 in the denominator works. 14 divided by 9 can be done. And obviously it can be done for here because there is nothing in the denominator. Anything over 1 would be just itself. All right, try this one. So first I'm going to factor this. So this becomes x minus 3 times x minus 1. I look at my denominators and I see, well, this is going to need to be multiplied by x minus 1. This is going to need to be multiplied by x minus 3. Okay, so that gives me x squared minus 3x right here. All the denominators are the same, so basically I can just wipe them out. If the denominators are all the same, then the numerators must also be equal to each other. And I'm going to add 1 times x is x, 1 times negative 1 is negative 1 equals, and this just stays 7. Combine like terms gives me negative 2x minus 1 equals 7. Then I'm going to set the function equal to 0, set the equation equal to 0. That makes this negative 8 equals 0. And this can be factored, I believe, to negative 4 and 2. X minus 4 times x plus 2. And I can now see my answers. So it looks like answers are 4 and negative 2. Now, I want to once again check to make sure that that's not extraneous. So 4 works here, x minus 1 and x minus 3, those are both right. Okay, so it looks like negative 2 is not going to be a problem either, so it looks like both of them are real solutions. All right, and I'm going to do one more. So we have 2 over 1, so this is x times x plus 4. All right, so we're going to multiply this by x over x and this by x times x minus 4, or basically just this. All right, so 2 times this. All right, so they're all going to have the exact same denominators now. So 2 times this would be 2x squared plus 8x. I basically just did 2 times this, which is the same thing as 2 times its factored form. Minus 3x and equals 12. All right, so clean that up a little bit. Combine like terms gives us 5x. Move the 12 to the other side gives us this. There is no GCF here, so it looks like I'm going to be dealing with a leading coefficient. All right, so I'm going to then need to factor it. So the way I do that is a times c, which is negative 24. And then I ask myself, what are the factors in negative 24? And do any of them add up to 5? So 12 and 2, that's not it. So 6 and 4 is not it. 8 and 3. So this is going to be split into 8x minus 3x. Of course. All right, so over on the left-hand side, that's going to give me 2x times x plus 4. On the right-hand side, it looks like it's just negative 1. Negative 1 times x minus 12. And no. X. Oh, that's negative 12. So negative 3 factors out. Sorry. Negative 3 factors out into plus 4. So it looks like 2x minus 3 times x plus 4 equals 0. And it looks like we have an answer of negative 4 for this one, and this one's going to be 3/2. Okay, so the 3/2 isn't going to be a problem, but if I put negative 4 in for x, negative 4 plus 4 makes 0, so this is actually an extraneous solution, and that makes this the only solution. All right, I am running low on time. I know I do have more examples, but I am going to stop right here. Thanks again for watching, and please look forward to future videos. Have a great day.